So in this lesson we're going to look at inequalities. Now inequalities, as is hinted at in its title, inequalities, we're looking at not equals, things that aren't equal. So inequalities are 7 is greater than 3. They're not equal, it's greater than. 7 is greater than 3. And, you know, when I first learned about this, it's the crocodile mouth, isn't it, facing the larger of the two quantities. So if I want to say x is greater than 5, then I'd write it like that. That means that is x is greater than 5. Okay, so what that would look like, if we want to look at that on the number line, it would represent that by, here's 5, okay, 0 is back here somewhere, x is greater than 5, not including 5, so we put an open circle around it, and then we draw an arrow in the right direction, in the greater than 5 direction, just hovering above this number line here. That's how we would represent x is greater than 5. If we wanted to, let's have a look at, say, x is less than or equal to minus 2. So that says x is less than or equal to. So that includes minus 2. X is less than or equal to minus 2. So whereas this didn't include 5, it was everything greater than 5, so 5 point bazillion zeros 1, that's greater than 5, not including 5 though. That's why the open circle, see the open circle symbolizes there that we're not including 5. But what do we do when we are including it? So this is x is less than or equal to minus 2, so we are including minus 2, which is here, say 0 is there somewhere. And so when we're including it, we have a big coloured in circle, filled in circle on, in this case, minus 2, and then less than or equal to, so we're going to the left. So what we're doing is representing on the number line all the numbers that are less than or equal to minus 2. Other inequality signs, we're not going to look at the not equal sign. The only other one we need to look at really is when x is between two values. So let's say our inequality signs always face the right because we go from smaller to larger. So let's say we're going between 1 and 5. What this says is x is greater than 1. So it's between two values. It's greater than 1. So this says x is greater than 1 and, not but, and less than or equal to 5. So that's what this statement here says, is x is between 1 and 5, including 5 but not 1. So on the number line, this would look like so. We'd have 1 here, we'd have 5 here. Now what do you think? We take x is greater than 1, so open circle around the 1. We're not including the 1, we are including the 5. So we'll fill that in. And we just draw a line, we connect the two, like so. So that's this particular inequality here. Okay, so now when it gets to solving inequalities, so solving inequalities, there's just a few things we need to be wary of. Okay, so solving inequalities. So let's say, for example, we want to solve 3x plus 2 is less than or equal to, let's say, minus 7. Okay, so here we've got an inequality because we've got a less than or equal to. So how do we go about it? Well, we treat it, we would proceed as if we're solving an equation. We wouldn't do anything differently. We want to get the x's on one side and the numbers on the other, keeping x's positive. So I would say here we've got 3x here, so there's no need to move the 3x. Plus 2 has no business on the left side, so we're going to drop him over onto the right hand side. In doing so, just as we did with equations, it becomes a minus, doesn't it? It goes from a plus 2 to a minus 2 over here. So we end up with minus 7 minus 2, which is equal to minus 7 minus 2 is minus 9. So we get 3x is less than or equal to minus 9. We then divide by 3. X is less than or equal to minus 3. And the job's done. And we haven't done anything differently there. That could have been an equal sign, and we would have proceeded in exactly the same way. Now, what we generally need to do, once we've solved an inequality, is graph the solutions on a number line. So 0 there, minus 3 there. You'll notice that I'm not using any scale here. That's all good. We're not too worried about that. X is less than or equal to minus 3. So it's a filled in circle, isn't it? Because it's including minus 3. Less than or equal to, arrow to the left, because less than is left. And that's how that would look. So that's not a lot different to how we have been going through questions. But what we'll have a look at is an example here where we will do something different. So just do a little example off to the side here, where I'm going to say 5 minus x is greater than 2. So I'm going to do that. Now, what I like to do is keep x as positive. So that would mean that goes over this side. But I'm going to look at two methods of doing this. Let's say we leave it as minus x and we take the 5 and take him over to the other side of the equation, leaving the minus x on the left. So what we have now is minus x is greater than 2 minus 5. So minus x is greater than minus 3 if you think 2 minus 5 is minus 3. Now, here's where things change. Minus x is greater than minus 3. I'm now going to divide by minus 1 here so that I have just x. Dividing minus 3 by minus 1 gives me 3 here. Now, what happens to the inequality, however, when we divide by a negative number is the sign switches direction. So x is less than 3. Now, if you think about that, that makes sense, because if x is less than 3, let's look at this. X is less than 3. Take a number less than 3, say 2. Put 2 in here. Minus 2 is greater than minus 3. That is correct. It is greater than minus 3. So if we had left this the other way around, which is what we would have done if it was an equation, this would have just been equals all the way down, and we would have just done this. This would be equals 3. But let's take a number, if this was the solution, x is greater than 3, let's take 4 for instance. Minus 4 is greater than minus 3. That's incorrect. So when you do a negative, when you divide by a negative or you multiply by a negative number, the inequality sign switches around the other way. Now I'll demonstrate that is, we won't worry about graphing that for the moment. Let's go back to the question where it was 5 minus x is greater than 2. Let's look at it doing it another way. Let's now pick up the minus x and put him on that side of the equation, because we do like to keep our x's positive. That means on the left hand side we've got 5. On the right hand side now it's 2 plus x, isn't it? Alright, so x is positive, but he's over that side of the equation, and we haven't done anything weird, so it's still the greater than sign. Now I'm going to take the 2 because he's got no business being with the x, so the 2 is going to come back over to the left. Now I've got 5 minus 2 is greater than x. So what I've got here is 3 is greater than x, but we like to have our inequalities facing, we like to have x on the left, don't we? So how do we rewrite this? It's x is less than 3. It's changing direction now because I've switched the sides of these two things, or more logically perhaps, the inequality sign is facing the 3, saying the 3 is the larger than x. So when I change direction, he still has to be drawn to the 3. I've still got to have the crocodile mouth open at the 3. So x is less than 3, same result as up there, as you will see. Last thing I'll say on this matter, just for the moment, why do we change the inequality sign to face the other way when we multiply divide by a negative? Well, if I've got, let's have a look at something here. 8, I'm sure you'll agree, is greater than 5. Yes, no arguments there. Now, let's put a minus in front of both of them. So in other words, let's multiply by minus 1. Which way does the inequality face now? Which is the larger of these two numbers? It's that way, isn't it? So what happened here is this switched when we multiplied both sides by minus 1, which is what we did here. Multiply both sides by minus 1, switch the inequality around. So keep that in mind, and you can't go too far wrong. Let's have a look at a couple more examples. We might do just do a couple out of the book. So 4 minus x over 3 is less than or equal to 6. So here again, what do you prefer to do? Do you like to keep your x's positive? Or do you want to do a sign switch at the end? I actually am going to go with him over here, and at the same time 6 is going to run away to the other side of the equation. So on the left hand side I've got 4, he hasn't moved. 6 has come across from the other side, so he's now minus 6. And on this side I've got x over 3 positive because it was minus, he's travelled over to the other side. 4 minus 6 is minus 2. X over 3 stays there. How do we get rid of x over 3? We multiply both sides by 3, don't we? So I end up with x minus 6 is less than or equal to x, or x is greater than or equal to minus 6. And on the number line, minus 6 is here. Always like to put 0 down. Give us as a reference point. Greater than or equal to, colour in, because it's also including, and greater than is that away. Okay, one more example. We're up to 11 minutes, so I've waffled on too long as usual. 3x plus 2, we're solving this, is greater than 6x minus 4. What should we do? So all our skills and techniques for equations we're going to bring into play here. Which way are we going to take? Look at the x's. Do you want to take the 3x over here or the 6x over there? You know what I'm going to do? I'm going to take the 3x and put him over there. Why? Because that'll give me a positive x value. So that means my minus 4 is going to skedaddle under the other side of the equation. So on the left hand side now, I've got the 2 that was always there plus the 4 that has joined it. Inequality stays the same way around. 6x, because nothing's happened, you only change that around if you multiply or divide by a negative. Now I've got 6x is there, and I'm now subtracting 3x because it's positive 3x there. So I've got 6 is greater than, don't forget your therefore dots, is greater than 3x. If you divide now by 3, we've got 2 is greater than x, and that reads the same as x is less than 2. So x is less than 2 is my solution. We can graph that quickly. There's 2, there's 0, and less than 2, open circle, isn't it? And going that way. Okay, exercise 1D is our next task, and on Monday we'll get into that. I'll see you then.